Okay, so we got done with our starting test. Now the next thing it wants me to do is my charging system. So it just tells me to rev the engine up with the loads off. Loads off meaning no headlights on, that kind of stuff. This is a little harder to do on a trainer because I'm not going to be able to turn the headlights on. I'll have to lie to it, but it won't be the first time. So I'm going to rev my engine up. And it detected the rev. Now it lets me idle the engine. So you're probably asking, how in the heck does it know the engine revved up from the battery? Well, remember, the electrical circuit starts at the battery and ends at the battery. Any changes in that circuit is going to be rippled and be felt at the battery. That's how this was able to tell we revved the engine, because the ignition system and fuel system are firing more times at a higher RPM. We're going to see that change at the battery. This is sensitive enough to pick it up. So now it wants me to rev the engine, detect it, idle the engine, push the return button. Now it's checking it idle. Hey, what are we doing? Now it wants me to turn on the high beams and blower motor, which is a little hard, and idle the engine. Again, it's looking for a change in the battery because, again, our electrical circuit starts at positive, goes all the way through our load back to negative. That's what allows us to see it. In this case, I'm going to push the inner button to tell it that, yeah, I did it. And it's saying, hey, we're idling. Now rev the engine with the load on. And it saw the rev and let it cycle through to idle the engine. And it tells me to turn off everything in the engine. Quiet. And it says my no load charging was 1438. Says my loaded was 1436. We know I didn't really load it, and that's why there's not much of a difference there. So keep in mind, all I'm testing the charging system for here is voltage. So although this will tell me if a system is undercharging or if it's overcharging on voltage, it won't tell me if I'm overcharging in amperage, which could in turn burn up my alternator internally. So this gives me part of the picture. This is going to give me the information for most of it, but that's why we have other tests. That's why I'd actually want to measure how many amps the charging system is producing. I'd also want to do a voltage drop on the charging system cable, because even if I have 14.3, maybe it's the alternator is actually making 15 volts and I'm losing voltage between the alternator back to the battery. This won't tell me that. That's why we have more than one test. It's not like I can do this test instead of another test. The tests go together to give us a complete picture of how the system's operating. So with that, let's get on to the next test. Okay, so we just used the Midtronics on testing the charging system. That told us the voltage, but that doesn't mean that that's the voltage the alternator is making. In order to see the difference between what's at the battery and what's at the alternator, I'm going to do a voltage drop test on the cable that goes between the alternator and the battery. The maximum voltage I'm allowed to drop on that cable is 300 millivolts. That's the only wire that we test on the vehicle that I'm allowed to have a 300 millivolt drop. And that's because of the size of the wire and the capacity of the charging system. Because I'm doing this on a trainer for access, I can't turn the accessories on and really stress the system. Normally when I do this test, I'd want to have the lights on and the blower on, or use the load tester here to actually create a load so I can really stress it out to see what the drop is. But I've been running this battery down pretty good doing starter tests, so I think that I should be able to get a reasonable result. So first thing I'm going to do is make my car start by plugging back in my electrical connector. And now that my car will start, at least it hopefully will start. What happens when you disable ignition and not fuel? Okay, so we checked it with our Midtronics, check our charging system with the battery. We can see we're charged with an acceptable voltage, but the voltage of the battery is not necessarily the voltage of the alternator. So what I want to do is I want to measure the amount of voltage drop in the cable between the alternator and the battery. And to do that, I'm going to do a voltage drop test the exact same way I did in the starter, except with a couple changes. First of all, my positive lead is now going to go on my alternator, and my negative lead of my meter is going to go on the battery. because the alternator, when the engine is running, is the most positive part of my electrical circuit. So that is the part where I want to put my positive lead on. The other difference is my charging circuit cable is allowed a 300 millivolt drop. It's the only circuit on the car I'm allowed that much of a drop, and that's because the cables are generally undersized because we're not charging at 100% capacity all the time. So if I turn the lights on, the blower motor on, air conditioning on, I'm not going to have that on all the time. So, or if I use my load tester here and take it to the maximum charging capacity alternator, my alternator doesn't work at max all the time. So that's why they allow more of a drop there. So with it hooked up, I'm going to start it up, and I want to take a look and see what kind of voltage drop I get. And I started up, and I have almost no voltage drop here. I'm at 1 millivolt. So I am not dropping anything on this circuit. I'm going to recheck my connections, and apparently it's a rounding error. There we go. Okay, so I got it hooked up, I got it started, and what I'm looking at here is a 400 millivolt drop. Now keep in mind, I'm charging the battery because I ran the battery down a bit, but that's well over my 300 I'm allowed. So I definitely have a high resistance fault. That means that my charging system was putting out 400 millivolts more than what I saw at the battery, which means I'm actually overcharging. I'm over that 14.5 volts I want. This right here will cause my alternator to wear out prematurely, where if I just look at it with Medtronics at the battery, I think the charging system is fine. This is where skipping a step and putting a car back on the road doesn't do the customer a good service. This is where it looks good at the battery. We know we're actually overcharging the alternator. That's going to cause the alternator to overheat, and that is also going to cause the alternator to fail prematurely. So that is something that we need to recommend to fix for the customer. Okay, so when we tested with Medtronics, one of the things we couldn't do is test amperage. So if I'm testing for amperage, I'm going to use something like this, an old AVR, or I'm going to use my amp meter and my DVOM or lab scope. In this case, I just set this up on DVOM mode. I'm going to turn my amp meter on, and I'm going to put this on the cable that comes from the alternator, because I want to know how many amps my alternator is charging. So I'm going to put this on the cable. In this case, it goes right across the top of the vehicle, which makes it pretty nice. I'm going to start the car. And I can see here that I'm reading. I started out about 58 amps. Right now I'm down to about 33 amps. And keep in mind, my conversion rate for my amp meter, as I discussed earlier, is 1 millivolt equals an amp. So I'm on a millivolt scale on my voltmeter, and that way I can just look at the numbers as they count up. Each of them is an amp. So if it's 33 millivolts, that's 33 amps. As the car continues to run, I should see the amperage drop because we're filling back up the battery. I don't need to do that as much, and the alternator only charges as we need a load, so it should drop down slightly. And right now, I'm down to 26. If I was in a vehicle where I could turn the headlights on, turn the blower on, I would see the amperage increase. And so I can actually watch it respond to load. Sometimes what will happen is we'll have an alternator that's too small. Maybe someone put a 55 amp alternator when I should have an 85 amp. So when I run air conditioning and other electrical accessories, I'm not actually making enough electricity to replace what's being used. So if I'm on a long trip, my battery might go dead while I'm on the freeway. So another possibility is I might have an alternator that's what's called full fielding, where it's overcharging all the time on amperage, even though the voltage is okay, and actually will burn the alternator up. So testing amperage is always a good idea. I don't need really a special tool. All I need is my regular DVOM meter, graphing multimeter, lab scope, and I need to go buy about an $80 amp clamp. I can put this thing on. I've just converted this tool into a whole other tool that I can do other things with. So again, we never want to skip this step when we're checking charging systems.